have. We are going to study power electronic devices for our GATE 2012 syllabus. So, first, for understanding power electronic devices, let us look at how does these devices differ from the normal electronic devices which we have seen till now. So, let us answer this question first. How does power electronic devices differ from linear electronic devices? So the answer to this question will cover a lot of characteristics of power electronic devices. So one thing which you all will say is that power electronic devices will handle a very huge amount of power, right? Sorry, that was a phone call. Power electronic devices will handle a huge amount of power is what you all will be thinking. Power electronic devices does handle very high value of power, but you should not have a misunderstanding that that is what differs, or that is what makes it different from the linear electronic devices. We have power electronic devices which can handle very low power applications too. For example, we have power electronic device which handles power in the range of milliwatt. That device is with you even now. That device gave a ring little while before, and that is mobile ICs. Mobile ICs are power electronic devices, and it handles only power in the range of milliwatts. So power electronic devices can handle power starting from milliwatts to maybe megawatt or kilowatt ranges. Okay, this kilowatt, megawatt applications are popular among all. That is why we have a misunderstanding that power electronic devices are used for high power applications only. It is not so. Now the second difference which it has from the linear electronic devices is that linear electronic devices has three modes of operation. Three modes. What are they? For linear electronic devices, you might have studied this. Cut off, right? Then you have an active region, and you have a saturated region. Where is this device operated always? This device is always operated in the active region, right? But in power electronic devices, we have only two modes of operation. One is on, second is off. So, power electronic devices is nothing but a switch. It has one on operation, off operation. Okay? It does not have this active part, which is a transition between this on and off. So that is another difference which you can say about power electronic devices to the linear electronic devices. Okay? Now, being understood what the differences are, let us go further to explore different power electronic devices. So the era of power electronic devices started with the production of SCR in Bell Laboratory. This Bell Lab is famous for a lot of discoveries. In around 1950s. Okay? 1950s, SCRs was found. What is SCR? SCR, I'll elaborate it now, and all the details about SCR will be dealt with when we deal this individually. Okay, it is silicon control rectifier. Silicon control rectifier. Okay, so after this SCRs were developed, there were a lot of rectifiers being used those days. These rectifiers are very much uncontrolled devices, and they were mercury arc rectifiers, which was a huge thing. Mercury arc rectifiers. So after the SCRs were found out, all the mercury arc rectifiers were replaced by the SCRs, and thus came the revolution of power electronic devices. And we see many applications of power electronic devices nowadays, which has been developed after this invention. Now let us understand the hierarchy of power electronic devices and go further with individual devices. Okay, so to understand the hierarchy of power electronic devices, let me say we have power semiconductor devices can be broadly divided into two categories: uncontrolled devices and controlled devices. So as I have told you, power electronic devices operates in only two modes, that is on and off. So what do you call those devices which operates only in two modes, on and off? Yeah, switches. So power electronic devices is basically a switching device. Isn't it a very big wonder that these switching devices have this much applications? Right? Yeah. So this power electronic devices are high frequency switching devices. So these devices are being controlled means, what is controlled? The frequency of switching is controlled. So only the time between two switchings or the frequency in which the on and off times are adjusted are all controlled. So there are devices which are controlled, which cannot be controlled. So uncontrolled devices are, we'll have a lot of accessories which are uncontrolled, which we will not be dealing now. And then we'll have certain rectifiers. These rectifiers are made up of diodes, Schottky diodes, etc. So this diode is what? Power diode. Okay, this diode is power diode. Power diodes, Schottky diodes. Though we'll be learning about the power diodes in detail as we go along with the course. Okay. Now we have control devices. Control devices can be divided into three: regenerating, non-regenerating, and integrated. Integrator is a very high level application of these devices, which is out of the scope of our syllabus, so we will not look at that. We have regenerating and non-regenerating. What is regenerating? Regenerating devices can pass power in both directions, forward as well as backward. If some power is going into the load, it can pass that power too. If load is giving some power back to the supply, that is called as what? Regenerative braking. Then it can pass that too. So that they are regenerating devices. Certain devices are controllable, but they are not regenerating. They will not allow power to pass in both directions. So there are two kinds of devices here. Now these regenerating devices are SCRs, GTUs. Non-regenerating is what we always see. MOSFET, IGBT, BJT. Just remember that all these devices which I am telling now are power devices. Okay, so this is the basic hierarchy of power electronic devices, controlled and controlled. So if you get a question like which power electronic device among the following is a regenerating controlled device, means you can give either of these two. Which power electronic device is a rectifier uncontrolled device? Then you can see this can be used in such a relation. So such questions can be framed from this. We'll look into some typical questions which come from this section, and then we'll go into the individual devices. Just give me a second. Let me rub this off. Okay. Now, for all the questions which I am giving now, I'll give some common choices. This will be the common choices which may come for all these types of questions. You will get a choice like A for MOSFET, MOSFET, metal oxide semiconductor field effect transistor. B, you have say an SCR. Okay. Then in C, you have GTO, gate turn off transistor, and D, IGBT. Okay. So the question now, yes, there will be around 5 questions. Okay. So the first is, which among these have the highest switching frequency? Highest switching frequency. Which among these have highest switching frequency? It is MOSFET. Okay, take a note of it. MOSFET has the highest switching frequency among all the power electronic devices. Then which of these have the highest voltage current rating? Voltage current rating is highest for MOSFET. It is highest for SCRs. Okay, voltage current rating is highest for SCRs. Okay. Then which of these have easy drive applications? Easy drive application. What is a drive? Any electric machine which is controlled for getting useful output is called as drive. An example is fan. Fan is a drive. How are we controlling a fan? Using a regulator. We can control the speed of the fan as per our load demand, right? So that is a drive. So easy drive application means which of these devices are most suitable for giving a variable voltage or variable current or variable frequency for a drive. Okay, so easy drive application is what it can be. It can be a MOSFET. Okay, MOSFET is having easy drive application. Now, which of these have gauge turn-off capability along with regeneration? So, if you see a gate turn-off capability itself, you can say that it is what? GTO. So, which of these have gate turn-off capability with regeneration? Both should be there. So it is GTO. Okay, and we have told that easy power application is a characteristic of MOSFET, right? But if it has to handle a very high power, then we will choose IGBT instead of MOSFET. So if the question was like, which of these have easy power, easy drive application, easy drive capability or application, along with high power capability. High power capability. Then we'll have to choose IGBT. Okay. So this the introduction to the power electronic devices. Now if you hear IGBT, SCR, BGT, everything, you'll understand that it is a power electronic device and it has some properties. And these are the basic questions which can come from these facts. So you'll not wonder what it is when you hear this. Now to get more familiar with all these devices, we will look at these devices in detail. The syllabus of GATE covers only the static characteristics as well as the basic operating principles of these devices. So that will be covered in detail in the further sessions. So this part of the lecture ends.